let's say you design something like uh, Google Maps, right? Uh, so how do you approach that, and what would you consider? Uh, what would you
Oh,
consider? How would you go about it, right? So design Google Maps.
sure. Okay, so I guess before really going into the details, I wanted to just make sure that I had the things that we cared about set out. Um, so I imagine when you say design Google Maps, the thing we care
Mm-hmm.
about is for what the user should be allowed to do, they should be able to, let's say, find their location,
Mm-hmm.
find a route between two destination points,
Mm-hmm.
uh, then addresses. Um, do we make any distinction between, cars, buses, uh, walking, things like that?
Mm-hmm.
Oh, so okay. So
Yeah,
give
you
multiple
mentioned, yeah, multiple ways to travel.
options. Okay. Give multiple transit options. Uh, is there any sort of, because I imagine it's not, full Google Maps, right? It's only some subset. Do we have, any considerations for real-time data like traffic?
Yeah, for now, let's assume that out of scope is you don't have to think about points of interest like
Okay.
restaurants and stuff. Points of interest. Assume that like you are given an address,
Right.
um, and if you want, like you can start with this designing for cars. We can leave out transit because that's a hard problem to solve.
Okay. Sure.
Um,
And I guess as well for the traffic and things like that. I guess that is something that you would care about, right? Like we can
yeah.
roughly talk about what you'd want to do for that.
Mm-hmm.
Traffic data. Sure. Um, the I guess also subject to some further constraints. It's probably helpful to you know figure out what some of the use might be. So realistically, I imagine that uh, Google Maps has 300 million plus monthly active users, right? So monthly active users, and let's say that on a specific day that there's going to be 100 million users that use it, and they use it maybe twice, right?
Mm-hmm.
Use it, DAU, each of them use it twice, meaning that you're going to get about 200 million route queries, route requests per day. So, that's a pretty large scale. And the thing that we care about is, of course, that this is highly available and we should have low latency for fetching routes. So, cool. Some error for route correctness is probably okay in terms of traffic.
Mm-hmm.
So one thing I didn't include is that routes should include ETA.
Mm-hmm.
Right. So starting right off the bat, I imagine something you'd want to do is to break your globe up into some sort of grid or hexagon pattern, right?
Mm-hmm.
Just because there's no way you can possibly keep all of the map data and all of the route data for the entire world
Right.
in single machines, right? Break up globe map into multiple squares or hexagons. Not possible to store on a single machine. uh, Given your route itself, you would probably, or given two positions, you need something to figure out which say, block Iran, as well as maybe, let's say you have your entire representation of your world through a graph, right? Like, I mean, that's exactly what Google Maps would do. If you were to have your address, there should be some service that resolves your address to some position on the graph, right?
Right.
Our world is represented on the graph. There should be some service that determines addresses on the graph, and for the lowest level of routing, you would just want to try and perform Dijkstras between those positions, right? So lowest level routing, Dijkstras nodes on the graph. Cool. So if we want to include routes, I imagine there's a pipeline, right, that you would actually end up going through. But when I imagine pipeline, that's normally an async task and not necessarily something that's a real-time system, right?
Pipeline is mostly an ingestion or a offline processing system, right? Yeah, go ahead. So we generally use pipeline for an offline or an async task. Yeah.
Yeah. So because there's a huge amount of data though, for the different layers you can use for improving your routes, I imagine that there is some set of tasks that you'd have to do async. What are you really storing, right? There's got to be a database portion of this somewhere.
So yeah, so I mean, after you break up, right? So we have broken up the globe into multiple squares, right? Assuming that you can solve this for a single square, right? I mean, we can go later into how to get routes across squares, but first, how would you solve it inside a single square?
Yeah, so when you mentioned routes across multiple squares, that on its own would not end up working out just because of the size of the graph, right? We're talking millions and millions of nodes, where I think Dijkstra's is something like it's V times E, or it's not it's a polynomial time algorithm, but it's not linear, right? So realistically, for calculating routes, you would not be able to calculate routes across blocks. So instead, what you would have to do is you'd have to break this apart into separate blocks, right? And within a block, you could use Dijkstra's, which I mentioned earlier. Sorry?
Yeah, we might need it across blocks, right? I don't know how big your block is. If your block is, let's say, the entire North American continent, you might not need routes across squares. But if your square is, let's say, Washington, and the next square is Oregon, right? Then you might have to find routes across squares, right?
Yeah, so I don't think naively you can just calculate all of the routes across squares. I think you have to do this in multiple steps, right? So
Right.
realistically, because of the size of the globe, your blocks wouldn't be a continent. It also probably wouldn't be a city, because even then you might have to do routes outside of cities, right? So let's say that the blocks end up being something like 5 by 5 kilometer squares, right? Maybe they're even smaller than that. Maybe they're like 2. 2. I'm not sure the details of how you would end up doing a multi-merge step where you run Dijkstras across all of them and connect them together, but I'm confident that that is something that we can do. In the sense that you would run Dijkstras on each of them independently on a separate process, and you should be able to have a merge step, which uses the result that you got from Dijkstras to get, instead of just a source and destination point, you would have, between all of the blocks, you would try to travel to a bunch of different positions that are close to the edge of the block, but and slightly closer to the destination, right?
Okay.
So it's not going to be an exact thing from the start to the destination. There's a bunch of intermediate calculations as well. So writing that down, add blocks. And I'm pretty sure that when you try to do, the separate step, one, you can run it parallel for the intermediate Dijkstras, which is pretty huge. And I'm confident that the merge step for merging the blocks is going to have a significantly lower runtime than running Dijkstra from start to end, right?
Okay.
So if you had the blocks separated, you would run Dijkstras at intermediate within blocks, find intermediate positions that are closer to the destination, parallel, and you should be able to merge some of your results quickly, faster running time than running Dijkstras on the entire graph. Right, so we didn't really talk about any of the services, right? So this gives you, this is, a super rough solution for how you might be able to find the routes, but what is the actual series of services that the user would go through? So let's say you have the client. For them, all they should have to do is just use a regular HTTP connection. Just because, you're not sending data back and forth in any way, right? It's just the single request response. So you're not going to have to make multiple TCP connections. And let's say that goes to our set of web servers. And from there, we would want to do a couple of things, right? It's the step is pretty much find route, then find ETA. Yeah, so it's almost like two separate steps. So let's say when we do this, there's no things like queues or anything involved, it seems, for the most part, just because the entire process seems synchronous. I think we might have to revisit that for how the routes may work out. But the part for where we, get some of where we calculate the route between the two destination points, that would have to go to some other server, which let's say it's called the route service, which is going to pretty much do what we said earlier. So it does all of these steps. And you would want to say normally place some sort of cache in between, right? But really, how are you, what are you really caching here? Because you can't just take the addresses. Even if you used an LRU cache and had, a significant amount of memory, is there really an advantage to keeping just the most recent searches? I guess maybe, potentially the user might research, right? Over and over again, and there's no reason that we should do that computation again. Yeah, so
that's the reason to. I mean, the probability of the user doing that search again is. Do you think the return is proportional to the amount of RAM that we would be spending to cache everything?
It wouldn't be everything. You would only be caching a subset of the data, right? So if you had even say a single machine filled with 100 GB of data of memory, it's this isn't even like a fault tolerant machine or anything like that. How many records could that possibly store? Let's say, probably not that many, right? Because it's each of these records, I imagine, would end up taking significantly more than, say, something like 500 bytes, right? Because it's a whole route, which is potentially a very long list of data. Yeah, so it almost seems like you couldn't keep that many records even if you had a single machine with 100 GB of RAM. I mean, if you had multiple, again, how likely is it that the users, like you asked, how likely is it that the user is going to search that again? Probably not that high. But if we, comparing that to the cost you would use in CPU for running these separate machines that recalculate, I'm not sure what the, without actually experimenting, I don't know how you could make this trade-off, right? So I think you'd have to experiment and then decide from there.
And then decide whether it's really worth caching, right?
Yeah.
Is it else that it is there? And so one more thing that that comes into play is the route. It's not constant. If you cache, sometimes the traffic condition might change, forcing you to invalidate the cache, right? It's not typical user data where it's highly unlikely that it would change, right? But here, traffic keeps changing every minute. So even if you cache you might have to invalidate because something happened. Let's say an accident happened on some highway, and you were forced to actually like take a different route. That has become faster now, right? So caching the route, I don't know whether it's a great idea.
Right. And okay, I was considering this without even, traffic, because I figure that's a separate layer, right? In the sense that when the web server tries to determine routes, there's separate layers for routing, traffic, weather, ETA. Or actually, I think ETA is the thing that has all these layers. So the routing service, if it's only calculating paths, it's not considering ETA. You'd have a separate ETA service.
No, the route service would have to take into account I mean, if you think route, there are multiple routes from the source to destination, right? And you cannot give the user multiple routes. So you might have to give the user the one with the least amount of time or like less miles depending on the user preference, right? So in that case, I would say instead of having separate services, I would say, I mean, can you use traffic as one of the factors? So Dijkstra's, you need some cost, right? Between nodes, just the cost of an edge, right? So can you use something like traffic as the cost of that edge? So Dijkstra's would automatically go and calculate the proper route based on. I'm just throwing off an idea, right? So
yeah, I guess if that were the case, when you decide to say create your graph for the routing service, it would call to the ETA service, right? So instead of the web server calling to the two separate services, you would still have your separate ETA service just because you want to separate the concerns, right? And at the same time, these should probably be independently deployable. But the ETA service can be a dependency, right? So in that case, if it were set up like that, you could still use the ETA information to update the info on the graphs so that Dijkstra is affected. So that is a possibility. So I think for the routing service, that's probably most of what we care about. We can talk about the ETA service for how that's used. So let's see. when you have ETA, you pretty much, I guess, want to have a series of layers that try to get data, right? It's
Mm-hmm.
still not clear to me. I imagine that this is one of the portions where you would actually have a database involved at all, because here's where you would actually end up reading from, well, I guess the routing service is also reading from some DB to get these routes, but the ETA service probably has a DB that's updating frequently, right? Versus the routing service, not really. I mean, how frequently are roads built or maps updated? So for the ETA service, here it seems like you would want to go through and for all of your weights, update them according to a set of map functions, right? So this is the thing where I think of it, where it's a pipeline, but it's not async. It's pretty much a synchronous set of maps, of map functions onto your graph. So let's say you would take distance, you would take traffic data, weather. They probably run a separate ML layer on top. Based on some set of data, you would have your graph weights go through some pipeline, right? So you would start off with just considering distance, and then you would look at traffic data, and then you would look at weather, and then an ML layer, and then you would have your weights, which forms your ETA, right? Or you would have your ETA forming your weights. I don't know if that's supposed to be the first way or the other, just because the routing service and ETA are so closely linked. Well, I guess really you'd have your ETA and then your weights, because the weights are routing service, right?
Or you could, you could have like two separate services, and then maybe learn which services you might. You can have something like the routing service returns top 10 based on the most frequently used routes, right? And then like the ETA service just adds weight on that, and then picks the highest one, right? So you could essentially say the ML layer is just a ranking where these routes go through this to get ranked. Yeah, you could do that.
Right.
In that case, you can have like two separate services, and the ETA services just takes the routing service output as the input.
Right. Yeah, and I guess the what is it? If we were to think of the differences between those, I guess for one of them, you end up increasing. If you were to generate 10 routes on the route service, you end up increasing the load quite a bit relative to the option of where there are dependencies, right? In a sense, I guess even for the ETA service, you end up having to do quite a bit of work versus maybe if they were related to each other, you would pick optimals along the way, right? On smaller graphs. Yeah, so I think this ends up being a lot of the, I guess, core logic. Typically, for a lot of these, I imagine you'd want to talk about bottlenecks. But it seems like we're not really talking so much about a data layer, right? So I guess we can talk about how the data would be maybe organized for the.
So sharding is one thing that that's very important, right? So how do you shard the data, and how do you make sure like your services are not just waiting for the other service, right? So like, do you have equal number of servers running route and ETA service, or
I imagine probably not. Realistically, it might be different, right? Just because it just depends on which one ends up needing more compute resources. Something tells me it's going to end up being the ETA one, but I'm not really sure. So right, so we can talk about what, say, potentially the structure of the data would be, right, or the how it's organized, not necessarily the structure, because for the blocks, to me, it's not really clear, what would you really store in a block, right, past the graph nodes. But if we were to, say, have a bunch of data, right, we would definitely need to partition this, and because it's partitioned, because we're running on the different blocks, the partitions would be in some sense based on the blocks, right? At least for the data associated with the routing service. And in that case, I imagine if you have some sort of auto-incrementing ID, you would want to shard based on that value. Because that way, what's likely is if you do round robin for your, determining which partition you should put your data into, it's likely to be equally weighted, right? There's definitely, that's not entirely true. Actually, when I think about this data, I think that holds for most data, but for this one, you end up having cities are the sections that are going to have the most traffic, right?
Yeah.
So let me think of that again. It should be, if you were to use round robin, it should be about equally likely that a city partition goes into any of those partitions, right? Or a city block enters any of those partitions. So I think the round robin thing is actually okay. If we were to just use some auto incrementing ID. So use auto ID and round robin to determine partition block goes into. And normally for something like this, I think it counts as some form as relational data, but it's not really the same, right? Yeah, this doesn't really seem to fit into the case of relational data for SQL, nor a key value store for NoSQL. There's graph databases, but those are usually between entities, right? Not blocks. But in any case, when we do decide to shard for either MySQL or for SQL or NoSQL, for both of them, we'll need to use consistent hashing to make sure that whenever we add or delete nodes, the amount of data we have to reshuffle is not the entire thing, right? It's only going to be a subset of the data that ends up being reshuffled.
Yeah, so one thing I would suggest is instead of using auto ID and round robin, you can just experiment based on like weighted population or something like that, and then make sure you shard passive things like, let's say, a national forest, and active things like a city on the same shard. So the national parks tend to have like a lot of area, so but less requests, and the cities might have like area and then like more requests. So you can kind of balance out those things instead of having an auto ID, right? Like if you have something like population, something like that, that weights these shards, and then that might give you an indication of where the request would go. That might be a better approach than using auto ID and round robin.
Right. Yeah, I guess it would depend after lots of experimentation.
Yeah. You could just say like, I'll experiment and then like shard or balance out based on how things go.
Yeah, I guess that would make sense, but I guess question for that is because I'm actually not sure for like separate from the interview portion, does that end up working out if you ever end up having to rebalance or reshard? Does that ever end up like wreaking havoc on your existing data, or is that never really a problem as long as you don't change your format, your scheme too much?
Yeah. So generally, like as long as you don't touch the data, right into the data. So, as you said, like there is very, very less chance that like a road is being built. So you could just, I mean, the map getting updated is like Yeah, it's very good.
Right, right.
The traffic,
Yeah,
yeah,
that
the
makes sense.
traffic data, yeah, keeps getting updated. But as you said, your route service is not consuming the traffic data.
Right, and it's pretty much
So
static. So
yeah, it's static. So I would say like having like a balanced model might work.
right,
And the rebalance is not going to happen frequently. So
but it's fine because
yeah,
it's not a real-time DB. Right. Yeah, that makes sense
yeah,
to
yeah,
me.
yeah. Okay, good,
Okay.
good.
I think that was it for the time that you mentioned, right?
Mhm. Yeah. So yeah, I think great. So yeah, this was my first. Yeah, you went went into a lot of detail. That's good. Good to see. Okay, cool. Thanks, man. So so what do you do?
What do you mean?
I mean,
Oh,
are you
right.
working?
So yeah, so I ended up finishing school, I guess the last term. Uh,
Mm-hmm.
but I guess for me, I've interned a couple of different times at like Uber and Facebook and other places.
Mm-hmm.
So I guess yeah, I'm not too familiar with the system design stuff except for like through engineering blogs.
Mm-hmm.
Yeah,
Okay, cool. Yeah, for a college grad, like I think you went pretty far, and good luck. And yeah, so yeah, yeah, you did very well. I don't have much of a feedback. You went and aced most of the questions I had.